In the WDM system, optical scheduling involved only multiplexing and demultiplexing in the initial stage. Multiple optical signals that carry service data at different wavelengths are multiplexed into a single beam for transmission over a pair of optical fibers, and then demultiplexed into different wavelengths at the receive end. Multiplexing and demultiplexing boards can be used to form a fixed optical add or drop multiplexer site, enabling wavelength adding or dropping and grooming at a site. To implement wavelength grooming, adding or dropping, on-site manual fiber connection is required, which is time-consuming and labor-intensive. To address dynamic wavelength management, the reconfigurable optical add or drop multiplexer is introduced. At its core lies the Wavelength Selective Switch, which enables precise control over wavelength pass-through and adding or dropping operations at any network node. By selectively allowing or blocking specific wavelengths, ROADM enable flexible wavelength grooming across the network without the need for on-site intervention, thereby delivering a streamlined and efficient solution. ROADM can be categorized into two types: direction-related ROADM and wavelength-related ROADM. A ROADM site combines the two types. First, the direction-related aspect. 1. Direction. Locally added wavelengths can only be transmitted in a fixed direction and cannot be dynamically rerouted. Compared with FOADM, ROADM use WS's boards on the line side and handle wavelength adding or dropping through multiplexing and demultiplexing boards. 2. Directionless. Local wavelengths can be routed to any optical direction. Compared with directioned models, the directionless models introduce a local degree to enable flexible grooming of locally added wavelengths. Next, the wavelength-related aspect. 3. Colored. At a given site, each add or drop port supports only a specific wavelength. The multiplexing and demultiplexing board is a typical example of a colored board. 4. Colorless. At a given site, each add or drop port supports different wavelengths. The WSS board is a typical example of a colorless board. Compared with colored models, the colorless models use the WSS boards to replace the multiplexing and demultiplexing boards for flexible grooming of locally added wavelengths. By combining colorless and directionless modules, we can enable flexible wavelength grooming without constraints on port or direction. ROADM also includes a contentionless architecture, which allows the same wavelength to be added or dropped at different ports on the same board at the same time. However, due to its technical complexity, cost, and integration challenges, contentionless modules have seen limited adoption. Moreover, wavelength contention is currently not a significant issue in most deployments. Therefore, ROADM sites based on the colorless directionless architecture have become the mainstream choice in the industry.